Hi class, my name is Moki. This is my course project presentations of the dataset that I choose and then the model that I selected. Let's do the dataset background real quick. Um, I didn't use the dataset provided by the professors in the book. I went out and find my own data. That's kind of related to work a little bit. I got approval from the professors for this dataset. The main response variable is the FTE. It's a full-time equivalency, the number of enrolled students in one community college in Colorado. This is the only data from that colleges. And then I have 9 regressors together with this FTE. The 9 regressors data is from outside of the colleges, like unemployment, population, GDP. There's 31 records in these datasets. It's a time series datasets from 1992 to 2022. I'm going to train the data with the FTE from 1992 to 2012 and then test it with 2013 to 2022 records in the datasets. There's no categorical data in this dataset. This is the 9 regressors that I find and choose for this projects. There's the national unemployment rate, Colorado unemployment rate, Colorado median household income, US median household income, US GDP, Colorado population, College County populations, College County net migrations. The College County data is specific to that county that the college reside. Next, I will do the variable selections and also the regression validations. First, I use the step AIC function in R with both forward and backward methods. You set the both equal direction equal both in the functions, and it will give you the best model. Next, I also run the backward method manually by selecting the lowest AIC, deleting the lowest AIC for that variables and then keep running it. I will show you in the next steps. Then I run the model significant testing on the model that was selected. Also run the extra sum of square methods to do a partial F-test on all the regressors. And I find these VIF variance inflation factor functions to check the multicollinearity between the regressors in the model that was selected. Now, the steps to do the backward deletions kind of manually. I use a drop one function in R. It will give you the AIC values, and first step you run the full model, and the US GDP was the lowest AIC, so I dropped that variables and run the second model without it, and then so on, and it will give you the stats for each steps. My conclusion is, as you can see, the R square adjusted is the highest in model number 4. The mean square error is also the lowest. And F statistic is not the highest, but it's quite high. And on top of that, these also match what step AIC functions recommended. It's the same model. So model number 4 is the one I selected after the variable selection process. Then I plot the FT with each variable that was selected. First is Colorado unemployment rate. Second was Colorado median household income. Third was US median household income. Fourth was College County populations. And the last one is College County net migrations. You can see that most variables show some linear relationship with the FTE data. So then I run the variance inflation factors. It will quantify the number for each regressors in the model. the rule of thumb that I learned about VIF is if it's more than five, means that there likely a multicollinearity exists in the model. The next step is to do the regression validation some more with the ANOVA table. As you can see, it's confirmed that the F statistic is quite large and the p-value is almost zero. Therefore, the model is significant. I also ran the sum of square for partial F testing for each regressors. As you can see, not all of them are considered significant based on the F table values. Only one is clearly not significant, is college county populations, but I included it anyway because when I play with it, if I remove something out, it's the statistics of the model is getting worse. So I decided I want to keep it. And it also matched what the step FIC function recommended as well. So I do more further analysis with residual analysis of the models. First is a normality probability plot. As you can see here, that it's look ideal to me. There seemed to be no issue with the normality assumptions of the model. Next, I do fitted model versus residual. In this case, I use studentized residuals. And you can see the points are pretty random in natures. The models seem appropriate. There are a couple outlier at the bottom right and the top right, but I don't think that too significant. Then, since I didn't find anything obvious to do a transformation on the model itself, I went ahead and do data validation with that model. And this is the result. As you can see, it seemed overfitting. The data validation show clearly that the predicted value is kind of way off. And the model works well with the trained data, but it doesn't perform well with the test data. So it's giving me a thinking if that what's happens here. So I look at the FTE by year for all the data in the data sets. As you can see from 1992 to 2013 over here, it has an upward FTE trends, which is typical usually. And then from 2013 on, it has a downward trend. And that's my test data lines. And if you see the predicted value for 2013, it come up pretty close. It's correct. It's almost correct. But from there on, it just went off the track because the model has an upward trend going on, and this is a downward trend. So the predicted values kind of go in different directions from this point on. This gives me a summary that the model is worked well with the training data, but it's overfitting with the test data. The VAF also shows some multicollinearity between regressors, and not all variables show as significant with partial F test. So in this case, I think we need more variables and more data collections. As you can see in the trend of the FTE in the past 10 years, it's a downward trend. So I need to study some more on what variables or what factor that might affect that. We kind of can tell from 2020 to 2022 because we have a big event happening, which is COVID. COVID changed everything. COVID changed the behavior of the students too. Before, as evidenced by many studies, that unemployment rate, the higher it is, the better the FTE. But it doesn't seem to be in this case in the later years, especially in the COVID years. So some more study needs to be done here. My conclusion is I'm not recommend this model yet. It needs more study on it. It performed well, really well in the trained data, but the test data doesn't show a good result at all. And so we need more data collection and more study. Thank you for listening and good luck on your final.